Okay, this is a positive term series, and looking at it, as n goes towards, we're going to use the, let's take a look at that. Positive term series. I can't use a test for a divergence, that wouldn't help me at all. But I'm going to look at this and say, maybe I can compare this to something that's somewhat related to this over here, all right? But I want to point out, you should know the sine function near the origin, right? This is sine of x. Really does look like it's the same thing, right? It's the same thing as x bar. It looks exactly like that, all right? So I'm going to say maybe this compares nicely to something that looks like this one over here, which I know is a convergent p-series. Now, I don't want to do the inequality, so I'm going to use what's called the limit comparison test, right? Let's write that down. So limit as n goes towards infinity of the sine 1 over n squared over 1 over n squared. Well, you know what? I'm kind of back in a familiar territory over here, but I'm going to write it a little differently. And I'm going to write it, it's sort of like with using continuous limits, a limit that I know about. I'm going to say x goes towards infinity, and I'll be sine 1 over x squared, 1 over x squared. I'm going to say this really the same thing as the limit as x goes towards 0 from the right side of sine of x over x, which I know is which I know is 1. It's a really pretty famous limit over there. So what have I shown here? I'm using the limit comparison test. I found the limit here is going to be 1. So what do I know about this over here? It's a convergent series by the limit comparison test. Thank you.